Hey everyone! Welcome back to the channel. Today, we're diving into a fundamental sorting algorithm that every programmer should know: selection sort. Now, if you're preparing for coding interviews, or just trying to strengthen your computer science foundation, this is non-negotiable. Without understanding selection sort, you'll struggle with basic algorithm questions. So grab a notebook, get comfortable, and let's break it down step by step. Section 1. What is selection sort? Selection sort is an in-place comparison sorting algorithm. What does that mean? It sorts an array without using extra memory for another array, and it does so by repeatedly finding the minimum element from the unsorted portion and moving it to the beginning. Here's a mental picture I like to use. Imagine your array is a series of closed boxes, each containing a number. The numbers are all jumbled up, and the boxes are scattered across your attic. You have a flashlight, and you start at the first box, looking inside each one to find the smallest number. Once you find the smallest number, you swap it with the first box. Then you move to the second box and repeat the process, ignoring the boxes that are already sorted. You keep doing this until every box is in order. Section 2. Step-by-step example. Let's walk through an example. Suppose we have this array of numbers: 9, 8, 1, 2, 7, 3, 6, 4, 5. Iteration 1. Start at index 0, assume 9 is the minimum. Move to the next number, 8. 8 is smaller, so it becomes the new minimum. Next, 1. Wow, that's smaller than 8. Update minimum to 1. Keep checking the rest of the array, nothing is smaller than 1. Swap 1 with the first element, 9. Now the array looks like 1, 8, 9, 2, 7, 3, 6, 4, 5. Iteration 2. Start at index 1, assume 8 is the minimum. Check the next numbers, 2 is smaller, so update minimum to 2. Swap 2 with the element at index 1, 8. Now the array is 1, 2, 9, 8, 7, 3, 6, 4, 5. And we repeat this process for each index until the entire array is sorted. By the end, all numbers are in ascending order. Section 3. How it works internally. Selection sort uses nested loops. The outer loop iterates over each element in the array. The inner loop finds the minimum element in the unsorted portion. After each inner loop, a swap is performed between the minimum element and the element at the current index of the outer loop. This repeated find minimum swap process is what sorts the array. One thing to note: selection sort is not stable. That means if two elements have the same value, their relative order might change after sorting. Section 4. Time complexity. Selection sort has a runtime complexity of O(n)(. Why? Because for each element, you scan the rest of the array to find the minimum. For small arrays, this is perfectly fine. For large arrays, it becomes inefficient compared to algorithms like quicksort or merge sort. The good news: selection sort is in place, no extra memory is needed, and simple to implement, which is why it's a great teaching tool. Section 5. Implementing selection sort in Java. Let's implement it in Java. First, we'll create an array of integers. Int array equals 8, 7, 9, 2, 3, 1, 5, 4, 6. To display the array, we can use a simple loop. For and I array system.out.printi+. Now let's define the selection sort method. Private static void selection sort int array for and I equals 0, I less than array.length 1, I plus in min equals I, for and j equals I plus 1, j less than array.length j++. If array j less than array min equals j. In temp equals array I equals array min equals temp. Here's what happens. Min keeps track of the index of the smallest number in the unsorted portion. The inner loop finds the minimum. After the inner loop, we swap array I with array min. After calling selection sort array, your array is sorted in ascending order. If you want descending order, simply change the comparison from less than to greater than. Section 6. Key takeaways. Selection sort repeatedly finds the minimum and swaps it to the correct position. It's simple, intuitive, and easy to implement. Pros. Simple and easy to understand. In place, no extra memory needed. Cons. Inefficient for large datasets, O(n)(. Not stable. Selection sort is perfect for small datasets, learning purposes, or when memory usage is tight, but for big data, more advanced sorting algorithms are preferred. And that's the selection sort algorithm in a nutshell. You now understand how it searches for the minimum value, swaps elements, and iterates through the array step by step. If you learned something new today, give this video a big thumbs up, drop a comment down below, and share it with a friend who's trying to learn sorting algorithms. Remember, mastering these basic algorithms is key to acing coding interviews and becoming a stronger programmer. See you in the next video, and keep coding.